Hello everyone. Today we will discuss the article Skeletal Muscle Mass and Distribution in 468 Men and Women aged 18 to 88 years old. This was written by Janssen and colleagues in 2000. There is growing awareness concerning the importance of skeletal muscle within different physiological and disease processes. Such concerns include the influence of aging on muscle wasting, as well as the anabolic effects of physical training on muscle size. Identification of individuals with low or high quantities of muscle mass requires normative data based on large and heterogeneous sample sizes, where skeletal muscle is measured using a criterion method. However, at the time this article was written, such data was absent from the literature. Studies have assessed the influence of age and gender on skeletal muscle. However, few have examined the influence of these variables on the distribution of skeletal muscle. Given the importance of skeletal muscle in both clinical and applied medicine, there is a need to establish reference values on the basis of age and gender. Understanding the independent influence of age and gender on skeletal muscle mass may be useful in the development of therapeutic strategies, specifically within the elderly population. These strategies are designed to preserve skeletal muscle, improve functional capacity, and to also decrease potential health risks. There is existing evidence to support the observation that MRIs provide precise and reliable measurements of skeletal muscle, and thus can be considered a criterion method for measuring skeletal muscle in vivo. Authors have previously reported a relative difference of 1.3% between MRI and cadaver sections of human appendicular skeletal muscle. The purpose of this study was twofold. First, the purpose was to establish reference data for total and regional skeletal muscle mass in men and women. Secondly, the purpose was to examine the influence of age, gender, and simple anthropometric measurements on total and regional skeletal muscle distribution. This study consisted of a total of 468 healthy subjects, 268 of which were men and 200 women. Ages ranged from 18 to 88 years old, and BMI ranged from 16 to 48 kilograms per meter squared. 199 of these subjects were studied in Kingston, and 269 of these subjects were studied in New York. Skeletal muscle measurements were obtained using a previously established MRI protocol. Researchers used the L4-L5 landmark as the point of origin and recorded transverse images, each of 10 millimeter thickness, every 40 millimeters from hand to foot. This resulted in a total of 41 images for each subject. A multi-step procedure was used to segment the various tissues of each given image. Area was computed automatically, and volume was calculated by multiplying that area by the slice thickness. Whole body skeletal muscle mass was determined using averages from all 41 images. Lower body skeletal muscle mass was calculated using the images extending from one image below the L4-L5 region down to the foot, and upper body skeletal muscle mass was calculated using the images extending from L4-L5 up to the hand. Body mass was measured to the nearest 0.1 kilogram with the subjects dressed in light clothing. Barefoot standing height was measured to the nearest 0.5 centimeter. Researchers determined the reproducibility of their MRI skeletal muscle measurements. This was performed by comparing the intra and inter-observer estimates for MRI measurements obtained from 3 male and 3 female subjects. Intra-observer difference was calculated by comparing the analysis of 2 separate MRI acquisitions in a single observer. Inter-observer difference was determined by comparing the analysis provided by 2 different observers for the same image. The overall inter-laboratory difference was 2.0 plus or minus 1.2. In discussing results, you can see that the men and women subject characteristics are displayed here in Table 1. The men were significantly heavier, taller, and had a larger BMI in comparison to the women. The men had significantly more skeletal muscle in compared to the women in both absolute terms and relative to body mass. The men also had significantly more skeletal muscle in both the upper and lower body segments. When looking at this figure, you can see that in comparison to women, men had significantly greater percentage of total skeletal muscle mass in the upper body and a lower percentage of total skeletal muscle mass in the lower body. Graph A shows a negative correlation between age and total lower body and upper body skeletal muscle mass in both men and women. When height was included with age in a multiple regression analysis, age remained a significant correlate of skeletal muscle mass in men and women. With both genders, age contributed significantly to the multiple regression model, which implies that there was a nonlinear relationship between age and skeletal muscle mass. A change in the slope of regression line occurred at about 45 years of age for both men and women. Within Figure B, you can see that the slope of regression line between age and relative skeletal muscle mass was significantly greater in men than in women, indicating that the age-associated decrease in skeletal muscle is greater in men. The subjects were separated into two age categories, 18 to 44 and 45 plus. Independent of gender, within the 18 to 44 year age category, total, lower, and upper body skeletal muscle values were not related to age. Within the 45-year age category, skeletal muscle mass was significantly related to age in both men and women. Within the men, shown in Figure A, age was significantly related to lower body but not upper body skeletal muscle. Within the women, shown in Figure B, age was significantly related to both lower body and upper body skeletal muscle. When looking at the relationship between body weight and height with skeletal muscle mass and distribution, height was significantly correlated with skeletal muscle in both men and women. There was a very low but significant correlation between the percentage of total muscle contained in the lower body and height within women. A greater height favored a proportionately larger increase in lower body muscle. Height was not related to the muscle distribution in men. Body weight was significantly correlated with skeletal muscle mass in both men and women. Figure A shows the relationship between whole body skeletal muscle mass and weight in men and women. In Figure B, when skeletal muscle mass was expressed as a percentage of total body weight, there was a negative relationship between skeletal muscle mass and body weight. There was a significant correlation between the percentage of total muscle contained in the lower body and body weight in women. Increased weight favored a proportionately larger increase in lower body muscle. Body weight was not related to muscle distribution in men. Figures A and B imply that whether whole body or appendicular skeletal muscle measurements are examined, the observation of a noticeable decrease in skeletal muscle begins after 45 years of age in both men and women. When looking specifically at the effect of gender on skeletal muscle, men have more appendicular muscle than women. Findings indicate gender differences for regional and whole body muscle mass. On average, skeletal muscle mass in men was 36% greater than in women. Women had 40% less muscle than men in the upper body, and there was a 33% difference between genders when examining the lower body. When looking at the effect of age on skeletal muscle, it is obvious that the substantial increase in body weight observed between 18 and 40 years of age is not associated with a corresponding increase in skeletal muscle. For both genders, the composition of weight gain before age 40 years old is predominantly fat. Consequently, skeletal muscle expressed as a percent of body weight is reduced relatively early in life. The loss of skeletal muscle mass with age was greater in the lower body in both men and women. The age-associated reduction in physical activity may be at least partially responsible for the change in muscle distribution with age. Researchers indicated that height and weight explained about 50% of the variance in skeletal muscle with both genders. A linear relationship was observed between muscle mass and height, whereas the relationship between muscle mass and body mass was curvilinear. The larger the increase in body weight, the smaller the relative contribution of skeletal muscle to the weight gain. In conclusion, this study presents reference values for whole body skeletal